So in this session, we're going to carry on looking at building chemical formula. So before we start, please make sure that you have your ion table whenever you're trying to build chemical formula. It is impossible unless you remember the ions off by heart to actually build chemical formula without the ion table. So please get used to using it, have it on hand whenever you're building chemical formula, and in the exam it will be at the back of any exams. Now, just a quick recap from last video on building chemical formula. We were looking at lithium chloride, so let's have a little look at that. So lithium, the ion for lithium is Li+, and chloride is Cl-. And what we looked at was if the charge, so remember this is 1 plus and 1 minus, is if the charge is opposite but is the same number, so 1 plus 1 minus, that would mean it would cancel out, and the formula would be LiCl. So that's the formula for lithium chloride. But we're going to move on this time, and what we're going to look at is where the charges don't automatically cancel each other out, okay? So let's have a look at magnesium chloride, and there's a few ways you can do this, but the way that you prefer is obviously the one that you find the easiest to work out. But I'm going to show you 3 different ways to work out the formula for magnesium chloride, and you pick the way that is easiest. My preferred way is the crossover method. Okay, so first of all, let's get the ions for magnesium. So magnesium is Mg2+, and chloride is the same as last time, is Cl-. And as you can see here, this positive charge and this negative charge won't cancel each other out, okay, because you have a 2 plus and you have a 1 minus. So when atoms bond together, what they're going to do is they want to be overall neutral, okay? So what they want to get is really they want to cancel this 2 plus, and this isn't enough. This Cl- is enough to cancel it out, okay? So because they want an overall neutral charge. So, and in reality, they're not bonding one to one. There's going to be billions of magnesium atoms reacting with billions of chloride atoms. You've just got to figure out, in essence, what the ratio is. So if you look here, you can see that this chloride ion will only cancel out 1 plus. So if we added another chloride ion, okay, that means we had 2 chloride ions, each one being a 1 negative or 1 minus, they would cancel out that magnesium. So what that means is magnesium, okay, would be 1 and chlorine would be 2. So what that is saying is we need 2 chloride ions to react with 1 magnesium ion. So that's the first way of doing it, where you just literally just work it out. So look at the positive charge and work out how many negative charges you would need. The other way that I've seen it being done, which I'm not really a fan of, but some people really like it, is to actually draw the ions as actually draw them as little circles and give them like arms or hands for each charge. So magnesium is 2 plus, so we would have 2 arms. And the aim of this method is to actually join an arm with another atom. So if we added chlorine, you can see that chlorine, Cl, because it's only 1 minus, it would only have 1 arm. So they join like that. And then because you can see this magnesium, it's still got this arm free, it can bond to another chlorine If you like that method, also that, that's fine. The final way, which is my preferred way, is the crossover method. So with the crossover method, you would write your ions. So we have Mg2+ and Cl-. But this time, what we're looking at is the numbers in front of the charges. So we have a 2 here. And I call this the secret number 1 because it's like algebra, isn't it? If you've got 1x, you don't write 1x, you just write x. So we know, because there's a minus, it's a 1 minus. So I'm just going to pop a line there, but you've just got to imagine that number 1 is there. So what happens is you do the crossover. So this number 2 goes down behind the Cl. Okay, so it comes across and down. And this magic number 1 goes across and down there. We actually forget the charges. Okay, so it's Mg1. Remember, if there's a 1, we don't write it. Cl2. So that, if we look at this, is the same as this. So in each of the ways that we've looked at it, it's still, all 3 ways make Mg Cl2. So here we have Mg and 2 Cls. Here we have Mg and 2 Cls. Okay, and and with this one, remembering that these 2 positives would cancel out these 2 negatives, and vice versa. Okay, let's look at another example. So this time I want to build the chemical formula for potassium oxide. So looking at our ion table, we need to find the ion for potassium, which is K+, and oxide, which is O2-. Okay, so the first method, you would just look at trying to cancel out the 2-. So we've only got 1 plus here with the potassium. So as potassium has is positively charged by 1. So that means we would actually need 2 potassiums to cancel out this one here, this O2-. So 2 positives, 1 from each potassium, is going to cancel out the 2- from the oxide. So that's the first way. The other way is to draw them, going back. So that means that you would need 2 potassium, so it's going to be K2O. Okay? Because remember that the overall charge, because you've cancelled all of these charges out, the overall charge is neutral. The next one was to do the arm method. So this time we have oxygen here, and it's got 2 arms because there's a 2 before the minus. Okay, and we need our K because there's only 1 plus, so it's only got 1 arm. And we would need to fill this other arm here, so we would need another K. So we've got K with 1 arm, like that. Again, it's going to make K2O. So let's have a look at the crossover method then. So we've got K plus and O2-. Remember, this 2, remember the crossover, it means that the numbers before the charges come across and down. So this 2 is going to come to here. So it's going to come across and down behind the K. And this secret number 1, okay, is going to come across and down behind the O. So we forget the charges. We don't bring the charges into this. So it's going to be K. And then it's this 2 is going to come across and down. So it's K2 and then O. And because the number 1 is behind it, we don't write the number 1. But regardless of which method you choose to use, that you should come up with the same answer. Okay, guys? Right, I'm going to leave that there today. Enjoy the rest of your day.